All right. So welcome to the Unit 4 webinar. And what we're going to do is we're going to go through the unit organizer and do a unit overview. Then we'll go and do a closer look at all the activities. I want to make sure people are kind of grounded in what's happening in the unit before we get the closer look at the activities. We'll take a look at the example unit organizer, and then we'll have some time for questions and answers and maybe a little work time at the end, depending on how long things go. So let's go ahead and get started on things. So here is the Unit 4 organizer, and it contains the interactive notebook link right here at the top upper left-hand corner. And as you scroll down, it's got the anchoring phenomenon and the lists of what targets we're hitting with this. And this is all about the forces that are between molecules. So what we do and focus on for this unit is going to be about sort of the chemistry of salad dressing, if you want to put it into that context. So it'll start off with looking at a unit opener slideshow about the ingredients in salad dressing: oil and vinegar and a emulsifier. And then sort of just looking through and doing a KWL Jamboard for that. Then you either can do the intermolecular force, intramolecular, which I call the bonding lab, with your students if you feel like you have the materials to do so, or we've built it into the interactive student notebook to be able to do it based on what they may have as common experiences, assuming that at least some people in your class have experience with like nails and oils and things like that. There is a simulation that's built into the interactive student notebook around salt and sugar solutions, and I'll show you that simulation in a minute. And they can go through and do that for task set 1. For task set 2, once we've got into and we've sort of gone through and learned what bonds are and at least covered them once, we review that again, and then we go into making ionic compounds. So there'll be like, how do we determine ionic charge? How do we put things together to make ionic compounds, and what are those compounds names? Then we go into covalent compounds. So we look at valence electrons, and we go through some slides on how to make Lewis dot models, and then we go through an activity of trying to complete Lewis dot structures and seeing how those relate to the properties of those materials. Finally, we get into the intermolecular forces lab, or what's going on between molecules. The geometry and polarity properties we had previously done with a PhET simulation, but that simulation runs extremely slowly on Chromebooks, which most of the students have. So we've kind of gone through and pulled pieces out from that into some slides. There's a part of the simulation that does work fine, and there's a part of it that doesn't. So we'll have them do the part that does work well on a Chromebook, and then we'll have them do the slides and their interactive notebook for the rest of the pieces. If you feel like you can get your students to do the intermolecular forces lab, there's a write-up for how you might do that with students by jigsawing it based on what they actually have at their house. If you feel like you can't do that, there's also an optional video for those lessons, so you can have them at least collect data and see what's going on with that. At the end, there's the review, and there's a Canvas quiz. And if you don't like either of those, you can go to the restricted folder and create a test for this unit. And finally, we have an engineering design activity around engineering your own salad dressing. So that's kind of what the unit overview is. And I'll see, are there any questions about that before we move into sort of looking deeper into what those activities look like? You can either unmute and ask or type something in the chat. I'm not really seeing anything in the chat. I'll keep looking at it though. And I'm going to go ahead and move on. Can I post the link to this page? Yes, absolutely. I'm going to go ahead and post that link. I'm just going to pause. All right. So I've dropped the link in the chat. And at this point in time, we're going to go into looking at some of these activities in greater detail. So I'm going to go back up to the top. And the first thing we want to do is open that interactive notebook. So that's right here. And when it opens up, it'll ask you to make your own copy, and the interactive notebook will look something like this. So now what we found is that although the interactive notebook is created in one large piece, sometimes students find it easier to use if you break it into smaller pieces. So if you're planning on breaking it into smaller pieces, I recommend figuring out which words from the word wall you want to put for that piece and breaking it along so that it has the essential question for that task set. And then you can see the headings here have the little bookmarks next to them. So you can go from the top of one heading to the bottom of the next heading, and that'll, or to the top of the next heading. And that'll usually make pretty easy break points if you want to break it up for your students. Now, the first activity is this unit opener. And the unit opener, I'm going to go back to our organizer. And here's the slideshow for that unit opener. I'm going to go ahead and open it up and kind of just show it to you briefly. And all it's doing in that unit opener is you're going through and looking at the properties of some different pieces of salad dressing. And it takes a minute to load. So just give it a second to load. And it's just going to have them go through and just sort of look at the different pieces in different ways. So for some reason it loaded to the end. If I go back to the beginning, you can see that it starts with just like a salad dressing, and then here are the different pieces, what they look like to you in person. Here is what the molecules look like, and we're not expecting your students to already understand what these means, just to notice and look that these look different from each other. Then we sort of talk about some of the other ingredients and then just ask them to go to a Jamboard and say, like, what do you notice? What do you think? And use this to sort of frame the unit for that there are differences between different compounds and that we sort of need to understand what those are. So once you've gone through that unit opener for the salad dressing, you get into task set 1, which is why does the salt dissolve and melt, not the sugar? So this is going into this PhET simulation. Now this PhET simulation is run on the browser link to Java. So it will run on a Chromebook, but it does take a while to load. So I would almost recommend that you get students to play with it while they're on an asynchronous time so that they're not trying to juggle their Zoom meeting or their Google Meets, which takes a lot of resources off of their computer, and have them just sort of play around with it. And there's several things that we want them to kind of play around and notice. One of them is that if I shake my salt, come on, salt, the salt comes out and goes into the water, that if I pull this conductivity piece over, that you can see that the light starts to get bigger. These little lines around the light bulb get bigger as you add more salt. Now, the questions in the interactive notebook are designed to try to tease that out of them, but if you feel like your students need more instruction, you might do a quick video for how they would do this. And as you add more salt, you'll see that it gets bigger and bigger. If I switch to sugar, the amount of the light doesn't change. And if you remove the salt, you'll see that all of the light goes away. So that's kind of that idea that my sugar is covalent, so it won't conduct electricity, and my salt is ionic, so it will. Now you can have them play around with the evaporation that causes the water to go away, or you can have them play around with this if you want to, which causes the dilution to happen, and that'll just change the concentration of the salt, which will change what's going on with the light bulb. But the other interesting thing is if you go to this micro tab, sorry, in the micro tab, you can also have them, when they shake in their sodium chloride, it's going to look like the representation of sodium chloride from the interactive student notebook. So the interactive student notebook has sodium chloride, as the ions are drawn as that green and purple, and in the water here, they can see that they separate. And with the sucrose, which is the sugar, you're going to have the molecules come out, and it is a little slow because I'm running my Zoom meeting at the same time. And that those sugar molecules stay as one piece and separate from each other as big, giant pieces. So that's what you want them to kind of notice as it goes through here. So when they go back to that interactive notebook, they can kind of have something to talk about with it. So that's what we're doing with that PhET simulation. I'll go back to the interactive notebook to show you what that looks like. So here it says, talks about shaking the salt, what happens, draining the container, refilling it, shaking sugar, all of those, clicking on the micro tab and seeing what happens when they go into the water. And then we have these images, I guess it's green and blue instead of green and purple, but you can see what the differences are between the images. We're expecting them to say that this one has the lines between it and this one doesn't. And that when they went into the water, these little all separated from each other and these all stayed together. And that's going to kind of put them through that first sort of activity. Now here, this is where you would either have them do the lab, or if you feel like you can't have them do the lab, you could just have them use this piece of the interactive notebook. Now, I didn't feel at my school that we could send home materials or guarantee that my students would have them because of the different circumstances they were in. So we just went ahead and gave them the pieces that I thought they wouldn't understand, and then had them substitute their own knowledge for the things that they would. I was hoping that as a class, we could get this filled out. And so for this, if you're doing it with the interactive notebook, they're just going to be thinking about, well, does the salt melt on a stove or not? Does it dissolve in water or not? And I put the conductivity pieces in. Now, if you want to be able to do it as a lab with your students, you could take that piece out of the interactive notebook or get it to match what's in this lab. This is compounds that people might have at their house or might not. You can jigsaw it based on what they do have. Now, this says Crisco and lard. Crisco and lard are not the same thing, but you can use them sort of interchangeably for this purposes of this lab. So if they have lard or they have Crisco, they could do either one, or you could decide to separate them out if you want to. Now, when this version, instead of having them test solubility, and that we're having them do a prediction for electrical conductivity, and this requires you as a teacher to be able to build a conductivity tester for them to do it in the live Zoom class. So in the notes for this unit, in the teacher notes, then I'll show you where those come from. So if you're in the bonding activity, these teacher notes right here that are linked at the top, it tells you how you might build a conductivity tester in like a snap circuit lab or some other kind of lab if you want to do that. I didn't feel like I was capable in that of having that available for me because my children have the snap circuit set and like to scatter it around the house. So I didn't feel comfortable making that all of our teachers would have that. So that's really up to you as to which direction you want to go with that. But if you do go that direction, then you can go through and have them make predictions and then talk about what those predictions are instead of just having them based on their experiences like it's currently written up in the interactive notebook. Now, once you've got them together, the part of this that's next, you're going to wind up sort of leading, and you can lead this either as a set of poll questions or as a Jamboard. You'll need to figure out what works best for you as a class or a formative, or you could just talk through it and have them respond to you in the chat. And the idea is that of these compounds, you're going to sort them into 3 groups. And just based on whether they conduct, you can see where the groups really should be. These top 3 will be in one group, the middle 4 will be in the second group, and the bottom 3 will be in the third group. And those groupings fit well with ionic, covalent, and metallic. And so you'll want them to kind of come up with those groupings and what elements are involved. So you'll get that your ionic has metals and nonmetals, your covalent has all nonmetals, and your metallic has all metals. And the reason for the electronegativity difference and the electronegativity average is you want them to sort of get the idea that if the difference is big, the electrons won't stay with one atom, they'll just go to the more attractive atom and they'll be ionic. If the electronegativity difference is small and the average is high, the electrons are stuck between the atoms. If the difference is small and the average is low, then they'll just sort of float around the outside. And that's what causes the different properties of the different kinds of compounds. And then once you've got this figured out, you can give them the names of what those 3 kinds of compounds are. At this point, you will have talked through it, but it won't gel completely in their minds. So, and I'm not expecting them to really walk out of this activity fully understanding bonding. So they're going to come back to that, and I'll tell you how that works in just a minute. But they should be able to say, okay, what we just talked about, I think I could say that maybe salt is ionic and sugar is covalent. That's all we're kind of getting to here. And that's the end of task set 1. Now, when you get to task set 2, you've done all of this stuff for task set 1. In task set 2, it's sort of fill in the blank based on what we talked about in our last class. So the idea behind this is you're circling back to that information, and hopefully by you going through all of this text, helping them really kind of get a better grasp of what's going on. So this is going through and talking about ionic, covalent, and metallic bonds, and just sort of filling in the details if they don't quite remember it from last class. And what you might do is assign students to fill this out as much as possible in their asynchronous, and then go through it in a synchronous class so that those people who don't quite get it get the answers that they need, and the people who do get it will get the a filling in of what it is in fact that they need.
Some guy.
Cora, I'm in the middle of trying to teach this. Can you tell me later? Thank you. Sorry about that. She always does a cameo. So that's kind of what we're doing here, is trying to make sure that the people who got it get their answer of like, yes, I was right. And the people who don't get some explanation so that they can understand. And then it kind of fills in like, hey, if I'm making popcorn, like what's happening to the different compounds. Butters are covalent, it's going to melt. The pan doesn't melt, it just kind of holds what's going on. And my salt, it stays together, doesn't melt, but kind of might separate a little bit on the things. Now, then it goes through, and there's a lot of text here that you might have them go through asynchronously, and then once again, cover what the answer should be as a synchronous session. And this is all about naming and writing ionic compounds. Now you can choose to do this before the worksheet, or you can choose to do it afterwards. I'm just going to show you what's here and then show you what the kind of worksheets are that relate to this. So this basically talks about what happens, how covalent compounds are made, how they relate to the Bohr model and to the periodic table, and sort of how polyatomic ions fit in there. And then it talks about practicing. Now what I would do for that practice, and if you go back to the unit planner, is it talks about there's an ionic charge practice and a compound formation with the Jamboard and a paper ion activity. So once they've sort of gone through there and they're ready to practice, the determining ionic charge, I'm going to pull this up. I don't remember. It's right here. This is basically just looking at the periodic table and sort of noticing that trend by going through that all of these things in the first column wind up losing their electron, and so getting a +1 charge. So it kind of steps them through that, like, hey, this has an atomic number of 3. It's in group 1, so it has 1 valence electron. It has, so they just kind of walk through that. And most people tend to sort of get this. There's a few that won't, that you might need to follow up with on an asynchronous tutoring there. But that'll kind of sort of get them in the mindset of like your row determines your charge for the most part. Then they can go into this Jamboard, and let me pull up the Jamboard here. This Jamboard, it's got compounds in it, and it's got pictures of ions in the Jamboard, and it's set up so that you can split people into breakout rooms and have them make as many of the compounds as they can. Now you'll want to make some sort of, it says right here that Control C is copy and Control V is paste. You'll want to reference that so that if people like, so originally it starts off with just 1 chloride. It changed because I was using it. This is that copy. When you click on it, you have to make your own copy. So I can say, oh, look, I made a compound here, but this is a +2 and this is a -1, and that's not going to balance. So I want to say Control C to copy it, Control V to paste it, then I wind up with 2. So I would say what I'm doing, state that this is here, and then I'll also put it in the chat as well. So Control plus C equals copy, and Control plus V equals paste. So if you state it, and then you show it that it's on here, and then you put it in the chat, then that usually starts to get people there, because oftentimes they aren't paying attention, or they get distracted at some point, or they walked away. But then it's all sort of somewhere in their awareness of what's going on. And then it's set up so that you can have a number of different groups going through and trying to make compounds based on this. So that's what this Jamboard activity is. And I usually have them go through that. And then once they're done, they can go through this formation of ionic compounds and talk about which ions they were, what the formula was, and sort of do the naming there. So that's how you're kind of getting them into the framework of what do I do with ionic compounds. You need additional practice. There's another set of practicing here. And there's some quizzes you can do if you want to put that in there as little quizzes to help out with that. The next part is this task set 3, which is all about covalent bonds and Lewis dot structures. So I tend to use this Lewis dot slides that are here at the bottom. And the way they go through, and here I should go back to the beginning, it goes through and it kind of asks them a few questions about what those valence electrons are, to just remind them of what we've been doing, because they're liable to forget between sessions. And then it goes through and talks through what the representation is with dots, how I would do an element, and then how I'm going to do it when I do compounds. So it starts with like what happens when I combine them together, and then it gives you some rules for how I would put those together and what those kind of compounds would look like. It looks like the link that's put in here right now is a link it's more of a PDF or a Google Doc. So I'll add the link later today for the Google Slides in case you wanted to make your own spin on this, because I know a lot of times teachers look at this and think I can do whatever a little bit better and want to make some modifications. So I'll put a link in there so that you can make your own copy and make your own modifications for that. Now, once they've gone through that, there is this Lewis dot practice sheet, and this is informative. So when you assign this informative, you can do this during a live session class, or you can do this during asynchronous, depending on how you feel about it. But when they're going through this, each one of these spaces is its own formative question. So they can fill in like the Lewis dot structure, they can color it in here in this background, in this square for that Lewis dot. And then over here, it says, what's the electronegativity difference? And it's kind of got your periodic table of electronegativities here. And then sort of saying what kind of bond is it. So that's kind of what this is doing. And it goes through a whole sheet of practicing how to do Lewis dot structures, what kind of bond it is, to kind of put those both in perspective. So that gets us through task set 3. Task set 4 is about the attractions between molecules. And so you could, if you want to, do this amoeba sisters. I don't usually tend to do that. I tend to talk about like, hey, when we went back into that original activity, we noticed that some of our covalent compounds dissolved in water and some of them didn't. Like sugar dissolved, but if I try to put oil in water, it obviously doesn't dissolve. So why are those things different? That's usually where I start with. So here are the slides that I have them go through. So it starts off, assuming that the slides would like to come up, with talking about smell and how when we add, we don't smell methane, but we smell dihydrogen monosulfide. And so it talks about through the chemistry of smell, and you can make this higher or lower level if you need to. Why do we smell? Goes back to that periodic trends activity we did in Unit 2, and then talks about how that relates to some of those bonds that are forming. And once again goes back to that. And then we get into this molecule polarity FET. Now, if I go, this is linked both from this presentation and it's linked in the interactive student notebook. So I'll scroll down here to get to that, because I find that having the links in the interactive student notebook makes it easier for students to access. So in this FET simulation, when I pull it up, there's 2 versions of it. There's the HTML version, which loads really well and doesn't take a ton of resources from your computer, but that only allows us to do this 2 and 3 atom, and we want them to do the 2 atom one. It's the real molecules that takes too much resources, and that's what we've resorted to the pictures. So in our interactive notebook, we're basically having them try all the different combinations between 2 atoms that we can try. And we want them to look at partial charges. I like to add bond character, and I like to add electron density. So I can say, where are my electrons going? So you'll find that, like, if this one's low and this one's high, all of my electrons hang out over here and it's kind of negative. Um, it says that that bond is becoming more ionic. Now, unfortunately, it doesn't give you any idea as to whether or not it's metallic. It's not into this in this simulation, so you can talk about where that would be. If they're both high, then I have that's going to be definitely my covalent. You'll want to talk to if they're both low. You might want to add that comment in there about, hey, the electrons can't pick one atom over the other because they're both about the same, but they don't really like either one of them. They're not really attracted to either one of them. So they also don't just float in between, they float all the way around, and that's kind of what's going on with my metallic bond. So the interactive student notebook has them go through each one of those scenarios. And I think that that's a thing that you could have them do. Just play with that simulation, get the answers that they can get while they're doing an asynchronous activity to play with that. Then you'll want to sort of talk to them about these activities here. And this is all sort of in the slides as well. So once they've gone through that sort of molecule polarity, and what I would do is I would introduce the activity, have them go through and play with maybe 1 or 2 of them, and then let them finish it up maybe as an asynchronous, and then come back and review the answers of what they got when you have your next synchronous class, and then have a discussion about what makes the polar bond. Now, what we do, you can do that, and now we have the. I would have them go into into a breakout room if breakout rooms are working for you, and have them discuss what is going on with these compounds. And this mirrors exactly what's in their interactive notebook. So if this is the picture that's in their interactive notebook, but that way they can kind of just have one thing open if they want to. And it's basically just saying, I've got these 3 compounds, they're both 1 atom. These are where I have both kind of medium. These are both high. And this was where one's medium and one's high. And you can see that on the one that these both have negative Celsius boiling points, and this one has a higher positive Celsius boiling point. So what is going on that's different here? Well, it's got 2 different elements, and it's got this arrow indicating that the electrons are all going one direction towards this fluorine. You get a little more complicated when you get 2 elements, and this is also in the slides if you wanted to look at that. And so here, these are all the same elements, so there's not really any kind of polar bond. Here, I've got 2 polar bonds, but they're pointed in exactly the opposite direction. So I usually talk about that as canceling, because if I try to talk about things as being symmetric or asymmetric, my students have gotten really good at saying that, well, this is symmetric. I can put a line of symmetry here. So, but they understand that if the arrows are exactly opposite, then they cancel. And here, these are negative, this is positive. These arrows point in different directions, so they don't cancel out. So all of my electrons are going to be over here by my oxygen and not over here by my hydrogen. When we get into the 3-dimensional elements that are a little bit harder to visualize, we flattened them out and showed that they look like in 2 dimensions because it's easier to see what's going on with the arrows in that case. You may end up with a question around difluoromethane about why the fluorine is here versus over here, because when you're first learning about Lewis dots, you might draw it either way. And if you do a search on the internet, you'll find that it's either way. It's worthwhile to pull up that PhET simulation because these are all in the PhET simulation as 3-dimensional molecules that you can pull up on a computer, but it's hard to do that as a student, but hopefully you can do it. You can do it while you're running a Zoom meeting, but you don't want it to load while you're running the Zoom meeting. So just have it staged on this molecule so that you can show them that those fluorine, if I move them around, I can get them to show either way. but however wherever they are on the atom, whether I show it this way or I show it this way, the actual arrows don't cancel out. So that's what I would do with that question. And then we have them go through the data itself and kind of look at what's going on there and get the idea that my atoms that have arrows that don't cancel out end up with higher boiling points. They're more likely to dissolve in water, which makes them more likely to smell. And that puts us back to our original question from the slides as to why do we add this to this in order to make it smell? Because this is more likely to dissolve in water and make it smell. Now, if you do wind up with a question, and occasionally you'll have some students that are super high end tag students who might go, well, I can smell some things that don't look like this. It's because they're heavier molecules that can still interact and kind of get through that mucous membrane. But it's because the reason we have to add it is because these are both really small molecules, and this is a small molecule that acts very similar to natural gas, but still has this smell and can interact with our mucous membranes. So that's task set 4. And the last thing that we have in this unit is the salad dressing engineering. Now, the design for the salad dressing engineering, if you click on it here, it kind of takes you through this big packet, and you might want to decide whether you want to break it up into pieces or leave it as a large packet. But basically, the idea is you've got this, you want to make an alternative salad dressing. This is written as though it's for Beaverton, and you might want to make your own copy and change it to your school district if you like. But the idea is you're going through and they're making a salad dressing. It's got criteria and constraints. These are sort of based on the idea of what things it should do and what things prevent it from doing that. Um, I have found that while it's valid to get 3 criteria and 3 constraints, I wouldn't be too picky on whether they've put constraints in the criteria and constraints. The fact that they understand what it needs to do and they understand what they can't do, they can't make, salad dressing made out of gold flakes, then that seems to be good enough. And whether they put them in the right column doesn't matter. Now, what you do is you have them test, there's 4 different tests they can do, and you can split it up where you have students do all of the tests, or you can have students do one of the tests and report back to their group, whichever way you want to jigsaw this, depending on how your time looks. But they each, for the emulsifier, they'll want to do like, they can choose some of these, whatever they have around their house: mayonnaise, mustard, dry mustard, tomato paste, honey, molasses, tomato paste, egg yolk, garlic paste. You could even throw in some other ones like oil, milk and butter, but those aren't as great of an emulsifier. And basically they're taking a little bit of vinegar and a little bit of oil, and they're mixing it together, and they're using some sort of stopwatch or timer to determine how long it takes before they separate. And that's going to be their test of their emulsifier. Then the ratio of oil to vinegar, you're using whatever's the cheapest vinegar and the cheapest oil you have in your house, whisking them together, and you're basically doing a taste test, like which one tastes the best to the people who are doing it. So you might have different results from different students because they might have different palates for tasting things. Then it's like which oil tastes the best of the ones they have in their house. Here are a bunch of recommendations. If they have another oil they want to try, it's fine. But they just, if they, I have truffle oil and I want to try it, sure. Or it's chili oil, okay, you can try it. But make sure that they, find out how healthy that fat is for them. And then which vinegar tastes the best. So and just have them taste whatever ones they've got around the house. And there's a whole list of them here that are suggestions. And if they come up with something that's not on this list and it's still a vinegar, it's still okay to do. They're making their own, and they're going to rank the taste on that. Now, once they're done and there's a little video you can watch about how salad dressing is put together, and you say it in your own words. Then they're going to make a label for their dressing and put out the cost. And there's an example of a salad dressing that's made, of how you would calculate out the cost and how you would write your nutrition label. So there's a couple examples there that help students go through, and some and so an example of like what are the pros and cons so people can say like, oh, what's good or bad about my particular salad dressing. So that is the salad dressing engineering, and that completes what's going on with this unit. Now I said that if I go back to my plan, my agenda, then we were going to look through the unit overview, look at activities, and look at the example unit organizer. So this is kind of how I put my organizer together, and I'll tell you where it worked and where it didn't work. I sort of thought that the unit opener could be asynchronous, that I'll just give you the link to this later. One thing that I found is that the Lewis dot activity took a little longer than what I had originally planned. Um, Part of that had to do with where it fell around the break, but part of that is just that sometimes people take a little longer to sort of wrap their brain around Lewis dots. And so you might want to plan a few extra days for this. And I'll drop that link in the chat when we're done with this. And also, I'll send you a link to this spreadsheet that has the agenda and this organizer when I send you an email in a couple days. All right. So that's what we've got for here. So what I'd like to do is stop the recording at this time, allow you to ask some questions, talk about any kind of learnings we've had from comprehensive distance learning or whatever you wind up calling it that we can share out with people who are online so that we can share what we've gotten. And then if we need some work time at the end, do that. So let's stop the recording.